Episode 9, titled 1.1 Recognize Data Types, Strings, Nulls, Numerics, Datetimes, Identifiers. The focus is why types quietly control every downstream decision in a data workflow. The CompTIA Data Plus DA0-002 exam often tests type reasoning indirectly, because many bad analytical outcomes start with a type mistake that looked harmless during ingestion. A column that should be treated as an identifier can be averaged by accident, a date can be interpreted in the wrong time zone, or missing values can be collapsed into a single marker that changes meaning. Type thinking is not only about what a value looks like, but what it means and how it should behave in calculations, joins, filters, and reporting. When types are correct, the rest of the pipeline tends to feel clean. And when types are wrong, the pipeline becomes confusing and untrustworthy. The aim here is to make type recognition feel automatic, so it becomes the first reflex whenever a dataset arrives. Strings should be treated as text, even when they contain digits, because digits do not automatically make a value numeric. Many real datasets include values like postal codes, account numbers, invoice numbers, and phone numbers that look numeric but are really labels. When these values are treated as numbers, systems can remove leading zeros, apply formatting, or attempt calculations that make no sense, and the damage can be silent because the values still look plausible. Strings also carry variability, such as upper and lowercase, extra spaces, and punctuation, which can create false duplicates or false mismatches during joins. Exam stems often hint at this when they mention codes, identifiers, or formatting changes after import, and the correct decision is usually to preserve the value as text. Treating strings as text first, and only converting when meaning truly supports it, prevents many common mistakes. Nulls are not just empty cells, because they represent different ideas, such as unknown, missing, not applicable, or not collected, and those differences affect interpretation. Unknown might mean the value exists in reality but was not captured, while not applicable might mean the concept does not apply for that record, and those two should not be averaged together. Missing values can also appear in many forms, including blank fields, special strings like NA, or numeric placeholders like -1, and collapsing them without thought can change the meaning of the dataset. Handling nulls responsibly often starts with asking what the absence means in the scenario, and deciding whether nulls should be excluded, imputed, or kept as an explicit category. On the exam, stems sometimes mention incomplete records or optional fields, and those cues often signal that null handling is part of the intended skill being tested. The safest approach is to treat null as meaning-bearing, and to avoid turning it into zero unless the scenario clearly supports that interpretation. Separating integers from decimals protects against rounding surprises, because integer fields and floating fields behave differently when calculations and summaries are performed. Integer values represent whole units, such as counts of events or quantities sold, while decimals represent fractional units, such as currency amounts, percentages, or measured quantities. When decimal values are mistakenly treated as integers, precision is lost, and the resulting totals or averages can be quietly wrong even though the dataset still looks clean. The reverse problem can also matter, because treating a count as a decimal may not break math, but it can signal poor modeling and can create confusion in reporting. In many systems, currency introduces special concerns like fixed decimal places and rounding rules, and careless type choices can cause small errors that accumulate into meaningful discrepancies. Exam questions often probe this by describing totals that do not match expectations, where the root cause is a type conversion or rounding issue rather than a logic error in the analysis. Datetimes require careful recognition because they carry multiple properties at once, including format, time zone, and granularity, and each property affects grouping and comparison. A date might appear as year-month-day or as day/month/year, and a wrong interpretation can swap meaning while still producing valid-looking values. Time zones matter because a timestamp can represent local time, coordinated universal time, or a system-specific time zone, and mixing them can shift events across day boundaries and distort trends. Granularity matters because some fields represent a full timestamp down to seconds, while others represent only a date, and joining or grouping across mismatched granularity can produce misleading patterns. Exam stems often include hints like a global user base, logs, or daylight saving shifts, which should trigger awareness that time zone assumptions need to be explicit. A strong habit is to name the date-time format, confirm the time zone context, and confirm whether the analysis needs dates, times, or both. Identifiers should be kept as labels, not quantities, because they are meant to distinguish records rather than participate in arithmetic. A customer ID, an order ID, and a device ID may contain digits, but averaging them or summing them produces nonsense that can still look like a valid number in a report. The main analytical role of an identifier is joining, deduplication, and tracing, which means the key questions are uniqueness, stability, and consistent formatting. Identifiers may also change across systems, such as when one system uses a different prefix or padding, and those differences can break joins unless they are normalized carefully as strings. Exam questions sometimes describe join failures or unexpected duplicate matches, and the underlying issue is often identifier handling rather than the join logic itself. Treating identifiers as text and validating uniqueness expectations protects downstream analysis from subtle integrity problems. Mixed types inside a single column are a common real-world issue and a common exam pattern because they cause unpredictable behavior in parsing and analysis. A column might contain mostly numbers but include a few strings like unknown or error. Or a mostly date column might contain a few malformed entries that were typed manually. Systems often respond by converting the entire column to the least specific type, often text, which then breaks numeric operations and sorting behavior. Another risk is that the system might coerce some values into nulls when conversion fails, silently losing information about why those values were invalid. Recognizing mixed types means scanning for outliers in format, unusual characters, and inconsistent length, and then deciding how to represent the column so the meaning is preserved. On the exam, this often appears as a scenario where calculations fail or produce unexpected results, and the intended move is to suspect type inconsistency rather than to assume the math is wrong. Leading zeros deserve special attention because they disappear easily during conversion and the loss changes identity. Values like postal codes, product codes, employee numbers, and account numbers often include leading zeros as part of the identifier, and removing them can create collisions where two distinct values become the same. Spreadsheets are notorious for stripping leading zeros when a column is treated as numeric, and some import tools will do the same unless the type is forced to text. The danger is that the conversion looks clean because the resulting values still look like normal numbers, but joins and lookups begin failing in subtle ways. Exam stems sometimes mention mismatched records after import or missing matches between datasets, and leading zero loss is a frequent root cause. The safe habit is to identify fields where leading zeros are plausible and to preserve them as strings from the start. Small, repeated value sets should be handled as categorical because they represent labels with a limited number of distinct values rather than quantities. Examples include status fields, region codes, product categories, and yes or no fields where the analytical value comes from grouping and counting rather than from arithmetic. Treating categories as categories improves clarity because it prevents meaningless operations like averaging status codes, and it supports correct visualizations and summaries. Categorical handling also ties to data validation because unexpected new categories often signal data quality issues or process changes that should be investigated. Exam questions sometimes test this by presenting a field with a small set of repeating values and asking what analysis or visualization makes sense, where the right answer emphasizes grouping rather than numeric modeling. Recognizing categorical patterns quickly is a strong skill because it guides both cleaning and analysis decisions. Bad dates can often be detected by spotting impossible months, impossible days, and swapped ordering that turns a real date into a wrong one. A month value of 13 is clearly invalid, but more subtle problems include day and month swaps where both are valid numbers, producing a date that is plausible but wrong. Another issue is inconsistent formats within the same column, such as some values using year first while others use month first, which can happen when data is merged from multiple sources. Time components can also introduce errors, such as a timestamp that appears to be in local time but is actually in coordinated universal time, shifting events into a different day when grouped. Exam stems may mention strange spikes, missing records on certain days, or mismatched totals across time periods, and these can be symptoms of date parsing errors. A careful analyst validates date ranges and patterns early because time errors ripple into every trend and comparison. Typecasting should be done carefully because conversion is an action that can change meaning, and it should be verified before analysis depends on it. Casting a string to a number can drop punctuation, drop leading zeros, or turn non-numeric entries into nulls, and each of those outcomes affects integrity. Casting a date time can interpret time zones or formats incorrectly, creating shifts that look like real patterns but are actually artifacts. Casting categories can collapse distinct values if trimming and case normalization are not handled consistently, which creates false grouping. Verification means checking a sample of converted values, checking counts of nulls created by conversion, and checking that ranges and uniqueness behave as expected. Exam questions often reward this cautious approach by offering options that include validation steps rather than assuming conversion is always safe. Tracking type changes matters because later explainability depends on knowing what transformations occurred and why. When a report is challenged, the explanation often hinges on what type decisions were made at intake and how missing values, identifiers, and date times were treated. Type changes can also affect reproducibility because a pipeline that depends on automatic type inference may behave differently when new values appear, causing a column to flip from numeric to text without warning. Keeping a simple record of type assumptions and conversions protects the dataset's meaning across time and across different analysts. This is also a governance concern because regulated environments often require clear documentation of how data was processed and what assumptions were applied. The exam often frames this as traceability, where the candidate must choose approaches that keep results defensible rather than mysterious. A type check ritual at intake is a practical summary because it turns many scattered concepts into a repeatable habit. The ritual starts by identifying likely identifiers and protecting them as strings, then scanning for null patterns and deciding what absence means in the context. It continues by separating integers and decimals and checking whether precision and rounding matter, especially for currency and percentages. It includes confirming date-time format, time zone context and granularity, and it includes scanning for mixed types and leading zeros that are at risk of being lost. The ritual ends with choosing categorical handling for small, repeated value sets and verifying that conversions did not create unexpected nulls or impossible ranges. When this ritual is applied, downstream analysis tends to be smoother because the dataset behaves predictably. To conclude, data types control downstream decisions because they determine what operations are valid, how values are compared, and whether results can be trusted. Strings often represent labels that must not be coerced into numbers. Nulls represent meaning that must be interpreted carefully. And numerics require attention to integer versus decimal behavior to avoid rounding surprises. Datetimes demand clarity about format, time zone, and granularity, and identifiers must be treated as labels that support joins and traceability rather than arithmetic. Mixed types, leading zeros, and bad dates are common pitfalls that distort analysis quietly, so careful casting and verification are essential. One useful next step is to choose one column from a dataset encountered today and speak its intended type out loud, then name one risk if it were typed incorrectly, because that reinforces the habit of protecting meaning at intake. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.